का बढ़ना तो दस्तूर है जहाँ का। उम्र का बढ़ना तो दस्तूर है जहाँ का। महसूस न करे तो डरती कहाँ है। मुश्किलों का आना तो पार्ट ऑफ लाइफ है। मुश्किलों का आना तो पार्ट ऑफ लाइफ है और इसमें से हंसकर बाहर निकलना यही आर्ट ऑफ लाइफ है। A very good evening to our respected faculty members, honorable guests from Hitachi Hi-Rel Power Electronics, and my dear friends. I am Nikhil Awad, third year Power Electronics student, and it is my great pleasure to be the anchor of today's session, along with your colleague Shishikala Prasad, who will be your co-host today. I welcome you all to today's event of Power Electronics Kit Distribution, a CSR initiative of Hitachi Hi-Rel Power Electronics Private Limited, Sanand. This event is organized under the MOU between Hitachi Hi-Rel Power Electronics Private Limited, Sanand, and Vishwakarma Government Engineering College, Chandkheda, with a aim to promote power electronics and make students aware of current scenario of power electronics in industry. Before we begin the event, let's start with a prayer to seek blessings from the Almighty. I would now like to request everyone to kindly stand to the prayer. To kindly take their seats. Now it is time to warmly welcome our respective guests. I request Dr. Amit Dwivedi sir, Head of Power Electronic Department, to kindly come forward and present the bouquet as a token of respect and welcome to our honorable guest. Mr. J.K. Soni, Vice President, Customer Support, Hitachi Hi-Rel Power Electronics Private Limited. Thank you, sir. I request Dr. Anand Trivedi to kindly come forward and present the bouquet as a token of respect and welcome to our honorable guest, Mr. Ramesh Ramanan, Vice President, R&D and Engineering, Hitachi Hi-Rel Power Electronics Private Limited. Now I request Professor Amrit Apnana to kindly come forward and present the bouquet as a token of respect and welcome to our honorable guest, Mr. Sachin Borisa, Associate Vice President, Supply Chain Management, Hitachi Hi-Rel Power Electronics Private Limited. Thank you, sir. I request Professor S.S. Swami to kindly come forward and present the bouquet as a token of respect and welcome to our honorable guest, Mr. Dhavan Patel, General Manager, R&D, Hitachi Hi-Rel Power Electronics Private Limited. Thank you, sir. I request Dr. A.M. Bhatt to kindly come forward and present the bouquet as a token of respect and welcome to our honorable guest, Mr. Dinesh Thakur, the Associate Vice President, Sir, Hitachi Hi-Rel Power Electronics Private Limited. Thank you, sir. I request MS Chandani sir to kindly come forward and present the bouquet as a token of respect to our Head of Department, Power Electronics, Dr. R. Dwivedi sir. Thank you for the warm welcome. It is my great pleasure to welcome all of you for today's informative event, which has been organized under MOU between Hitachi Hi-Rel Power Electronics Private Limited, Sanand, and VGEC Chandkheda. Power electronics is a rapidly growing field with application in electrical vehicles, renewable energy, motor speed control, power supplies, and whatnot, which has shapes the future of technology. Hitachi Hi-Rel Power Electronics had undertaken an initiative under CSR to spread awareness about power electronics and its crucial role in modern day industry and society. This event is aimed to successfully achieve this goal. Let us all cherish this opportunity and make the most of this. And enhance our knowledge. It is crucial to utilize electrical energy efficiently. In this world, where power electronic plays a very important role in same by converting, conditioning, and controlling weather effectively using the electricity. Today's session is a great opportunity to learn about its importance and career scope. So I request everyone to stay attentive and make the most of the session. Feel free to interact with our esteemed speaker for any doubt or any questions. Then with I invite Professor H.S. to brief us on the event. Let us welcome him with a big round of applause.
So, good evening, everyone. Uh, First of all, I welcome everyone, all the guests, Mr. J.K. Soni, Mr. Ramesh Ramanan, Mr. Dinesh Thakur, Mr. Dhaval Patel, and Mr. Sachin Burisa, and all the team from Hitachi Hi-Rel. We are really thankful to them for their continued support ever since, as I remember, since I joined VGEC, since 2011, they are supporting our brand. They are the core industry of power electronics, right? Since it has been almost 15 years, with more than 15 years, we are collaborating and doing some, this and that work, which is aimed towards the benefit of students. Recently, we had signed an MOU with Hitachi Hi-Rel Power Electronics Limited, and under this initiative, we had already done certain works. This year, uh, it was a nice idea from Hitachi Hi-Rel to distribute a small kit of components which are generally used in power electronics, right, everywhere, which consist of various transistors, MOSFETs, resistors, Arduino, some soldering devices. This is aimed towards a learning practice for you people that how by getting this kit at least you'll be able to know that which are the components, core components that are used. At least once you start with something, see everything. As I know, everything you need to start somewhere, right? So this it is a just a token kind of thing. You start with one transistor, one MOSFET, maybe one IGBT, a resistor, different types of resistors. Once you start, you'll be able to do something more, and after that, you may be able to achieve something more. That is the main aim behind this thing. This kit was very meticulously formed or maybe designed by Mr. Dhawan Patel and Ramesh sir. It was very, they had very decisively selected the component, that which component should be given, how they will be useful and all, right? Apart from that, uh, this whole exercise is aimed towards creating an awareness about power electronics, right? What is the future of power electronics? What are the job opportunities? How it is useful? Yesterday also we had a session about the same. Today, see, there is no lecture today. Like as we are expecting, yesterday there was a proper lecture on this thing. Today we don't have a lecture, so please keep this session a bit interactive, right? If you want, see, we have very senior people here who have been working since their whole life in power electronics. They are really experts, and they have worked almost more than 30 years, I can say, in the field of power electronics. You can ask them from starting from the history about power electronics in the coming future as well. So I request all of you to be attentive and try to not just listen, try to have some questions, do some interaction. If you have some doubts about anything, about your career, about the company, about different fields of power electronics, anything you can ask, because today we don't have any lecture, right? So please feel free to interact with the honored guests. Okay, so I welcome all of you on behalf of VGEC. Thank you.
Thank you, sir. Next, I will request our esteemed guest, Mr. Ramesh Ramanan, to enlighten us about power electronics.
पड़ता है ना उसको uh, Good evening, everyone. Am I audible? Okay. To begin with, thank you for your patience. I think we were delayed quite a bit. So hopefully we'll make this session a little worthwhile. I've been informed we are discussing power electronics today. Uh, I think there'll be a lot of questions from you. There's a mixed faculty students, I believe, electrical, electronics, and power electronics. So we belong to the domain of power electronics, our company. So I mean, you would be, introduced to power electronics with the probably the sentence that power electronics is the science and art of controlling large power, with microelectronics. I mean, in today's world, it goes beyond that. My favorite definition today is that power electronics is the science which will make the earth a better place to live. You know, all the products that we do, all the services that we offer, the research that we do, they are all towards what we term sustainability goals. So if you guys read about climate, you read about, I don't know, UNESCO, UNICEF, WHO, they all have sustainability goals, all of these international bodies. So there is a target to reduce the global temperature by about 3 degrees by 2040 or 50. I'm sorry, I don't remember the figure. How is that going to be done? Because the main culprit as identified is I mean the conventional fossil fuels, thermal power plants, etc. So which is where power electronics comes into play. So power electronics will play a very very key role in reducing pollution, reducing the ambient temperatures, reducing the overheads on our air conditioners, all of our devices that we use today. And I think the first thing you would probably think of is solar energy, as she mentioned, electric vehicles, uh, many more things like recently with the LPG shortage, I mean, induction cooker, induction heaters, induction cooktops, they came into sharp focus. It's like necessity being the mother of invention. It was already there, but then, things start getting used widely. It's like what COVID taught us, conventional energy sources, which are, I mean, limited in supply. That is what I would define power electronics as. I mean, the means towards making our earth a better place to live in, a healthier place to live. Now, if you look at the engineering of power electronics, I mean, the subjects that it covers, I mean, we would have people from electronics, mechanical, environmental engineering, all the core faculties that we call. I mean, they are always evergreen. There's nothing, engineering is not possible without those basic courses that we talk about, chemical, mechanical, electrical. When I used to study in the 80s, I think those were the only faculties prevalent at that time. Power electronics, it has the distinction, or rather, whichever way you look at it, I mean, it has the distinction of being a combination of many disciplines. We have electrical engineering, electronics, microelectronics, we have microcontrollers to control large inverters. We have mechanical designs because uh, once you should have a look at the field where very large inverters are installed or very large VFDs are installed. So they are huge. So mechanical engineering is a very key element in that. Over and above that, I would look at thermal engineering or heat dissipation as the biggest challenge we have today on these. So you hear about diodes, thyristors, bipolar transistors, MOSFETs, IGBTs. Now we are talking about silicon carbide, gallium nitride. I mean, these are the evolution of hardcore power devices. But then we now have to find effective means of utilizing them to our advantage. Getting an advantageous or a better device, I mean, it's not the end of the story. So when you go to higher switching frequencies, you have the challenge of EMI, EMC. You have the high challenge of very high heat dissipation in small areas. So I think all of you, Gen Zs, Gen Alpha, Gen Beta, you know mobiles better than us. So you would have heard of iPhones now employing vapor phase cooling, you know, phase change cooling. So that those are means of cooling down a very large amount of heat in a concentrated area. So that again is because within the phone you have chips working very fast at very high frequencies. So you would have to have innovative means of cooling the whole thing. So if you look at larger computers, or if you have, I think you're using ANSYS somewhere, you might be having higher end desktops. So they are all cooled by what we call heat pipes. Some of them even employ liquid cooling. So which basically means that if you choose power electronics, you are in for just not electrical engineering, just not PCBs or devices like transistors or thyristors. You would then have to learn many, many disciplines to become a really good power electronic designer. So you would need to look at how to cool. You need to look at how to build mechanical things. You'll have to look at how to prevent radiation, conducted radiation. You could have, a lot of noise going around. So which is why a lot of tests are done. All labs nowadays, they have EMI, EMC test facilities. So that is the prime requirement of any equipment to be put into the field. That is certification for radiation. So you'll have to challenge that. You have to look at how to control them because demands on the controllability are very, very high. You look at a very simple thing like a fan regulator. None of you would have seen it, but in our generation, we had something as large as that switchboard there, resistive fan regulators. You have something as small as the switch today. It's because you either have a capacitive switch network or you have a triac controller. So that is power electronics for you. And it has now advanced to BLDC, brushless DC motors on the fan, so which allows you to have stepless speed if you require, and they, you know, result in a lot of energy saving because when you reduce the fan speed using resistors, you're reducing the fan, but the speed. But then what you're doing is like, you know, reducing the speed of your car or your bike by using the brake. So you do achieve the function of speed reduction, but then you are wasting the energy. So, but when you utilize innovative methods which are new, you result in something energy saving which is unheard of, which is something exponential. So, which is what the variable frequency drives do. You have Bernoulli's law, you have Pascal's law, so utilize them for flow. When you reduce flow rate by throttling, you are wasting energy. If you reduce flow rate by reducing speed, you are saving power as the cube of your speed. So, which is where you can recover the money you invest in a variable frequency drive. So, the key to reducing ambient temperature, to reducing stress on the environment is to reduce the amount of energy we spend or the greenhouse gases we generate or the amount of heat we generate, release into the environment. So when you save energy, it's as good as energy produced. And secondly, it's as good as reducing your temperature of our environment. So, that is what I would like to update you about that power electronics, I think till now has been like not a preferred batch, I would put it that way. The last preference maybe. But then, it's a fact now that that is what is running the world now. All of the Facebook, Instagram, whatever you guys use, they run on very large data centers which consume megawatts and gigawatts of power. So if you don't have that continuous power, you are going to have, a world without Instagram or Facebook. I mean, चुलम चिल्ली होती है 5 मिनट का आउटेज होता है एवरीवन इज वरीड व्हाट्सएप नहीं चलता है बट देन ultra reliable power sources work in the back end to ensure that you never see a drop in call, you never see an outage on your Facebook or Insta or even when you're working on your laptops. So that's it from my side. I think as sir said, let's have it an interactive session. Dhaval san, JK Soni sir, they are all experts and with a lot of experience in this field, so a lot of queries we could reply to you depending upon the time we have. So thank you again for having me here, and I hope we have a good session today. Good luck to all of you. Thank you.
So, for the information about power electronics, next I would like to request our esteemed guest, Mr. J.P. Snevi, to elaborate on the event.
Yeah, thank you very much and good evening to all. See, when we talk about a power, first of all, we should demonstrate the power. We should have a power then and then we can control the power. Otherwise, the thinking of controlling the power is very difficult. So one has to have a spirit. That's a good evening. Yeah, that's good. See, if we talk about growth in power electronics, uh, the company where I am working, which is on a previous day, it was a Hi-Rel Electronics. I have joined this company in 1987. Uh, you don't think at that time we were making a variable frequency drives and UPS. Variable frequency drive, we have a design from the US. And you don't believe we are making 2 horsepower drive like this. It is almost a 1500 mm or a 1400 mm height and maybe having a 600 mm width. You see the level of technology at that time. And down the line, 20 years, people are keeping 2 HP drive in the drawer. You see the kind of the pace of the changes in the design. At that time, when we see a 10 kilowatt or a 20 kilowatt UPS, we were surprising see it's a higher rating of the UPS. Today, we are talking of a megawatt. Even you look at the solar inverters, you look at the variable frequency drive in a 6.6 kV, 11 kV, where the people are making, even the HHP is making a for 30 megawatt drive, 24 megawatt drive in a 11 kV. So this is the growth of power electronics in last 3 to 4 decades. Even today also you see when we talk about the power electronics in 80s and 90s, when we talk about the power electronics, people are thinking about the power transistor and thyristor, and people are not able to think anything beyond that. And today you see at that time, what we talk about a switching device, now we are talking about a power board. The whole things have been changed to from device to the board. Even for the 40 ampere, 100 ampere, people are putting the stack in the board. So this is the kind of a change in last 30 years. Even you talk about the today the many people are aware about the C port, which is the most popular port for the charging of a laptop, charging of a mobile. So you are aware it is a bidirectional port and it can handle 6 ampere current. So it's a power. You just look at a very small device and it can control the 6 ampere power, 60 watt or a 65 watt power. So just very small device and which can adjust to the ODD of the any device. See, if you look at a USB-A, which is compatible to some of the devices, but when you talk about a C port, then it is compatible to many devices, and it can control the devices at the many voltages. So this is the growth in the power electronics. So we cannot think anything without power electronics. You name the thing, and there is a power. And today also, see, whole day, if you look at this. Strait of Hormuz problem and America, Israel, and Iran war. Everyone is talking about the energy. They may be in terms of a crude, but they are talking about energy. So, for our life, it is very important that we should have energy and then control on energy. See, these days we come to know that India is having a 45 days reserve. You just think in the country of 140 crore people, and then we are holding a 45 days of oil reserve. It's just such a huge capacity. You just see what kind of power and what kind of energy we are storing at the different location of the India. So without power, our life is nowhere. Uh, as you can see, our company is taking a lot of initiative in developing the people. Even in my tenure in at our HHP, we have developed so many people in the particular field, and people have joined as a junior. Even myself has also joined as a junior engineer, and I am holding a head of a CSD position. So I request that there is a very good future in the power electronics. And we are taking an initiative, and that's why we have taken up this thing that we are distributing a kit where many components are part of that kit. You should look at the part and you should go into the detail. See the variety of components are there in the kit. So you try to learn, try to go into the detail. See, design is in the books, but design is on the our around surrounding. If you have to find out the eye, how you can understand. If you look at the mic, then also you find how it has been designed, right? So in all these components, there are wire wound resistors, there are sockets, there are certain crimping terminals, there are chips. So please try to go into the detail of each and everything and try to learn the application of those components. See, you look at only a capacitor, but there are a variety of capacitors. Electrolytic capacitor, multilayer ceramic capacitor, paper capacitor, and you have to understand the application of each and every component and where it is to be applied. So I think this will give you a better understanding and better knowledge on the components. Yeah, but see, I am stopping myself over here, and I wish you all the best. Okay, thank you.
Next, I will request our esteemed guest, Mr. Sachin Devasya, to say a few words.
Good evening, everyone. Sorry, I was not prepared for this. How to this? Thank you. So, as such, I don't have any story as of now. Uh, but I can share my own thoughts because I was not even prepared in my childhood to become an engineer. But luckily and luckily, I became an engineer. So, when we were, playing in the early days, like 90s, uh, actually, wait a minute, geography की class है? Sorry. તો અત્યારે જે કિસ્સો સંભળાય છે ગુજરાતમાં મજા આવશે એટલે તો આપણે નાના હતા ત્યારે પાવાગઢ બનાવતા હતા માટીનું હવે ત્યારે અમને પછી નથી કે અમે એન્જિનિયર છીએ બાળક એટલે ત્યારે એટલે પાવાગઢ બનાવીને નવું નવું કંઈક કરવાનું મન થાય એટલે પહેલા તો ભગવાનની માતાજી પાસે પેલું ચક્ર બનાવ્યું ચક્ર બનાવવા માટે આપણે ભેગ ભેગ ભરવું પડે અને મોટર બનાવવાનું બધી મોટર મળતી નથી હા એટલે પેલી વોકમેન હોય ને વોકમેન કાં તો ટેપ આવતી હતી તો એની મોટર તોડીને પછી એની ઉપર ચક્ર લગાવીને માતાજીની પાછળ લગાવીએ અને ચક્ર કરાવીએ ઓટોમેટિક એટલે એવું કે ત્યારે ઇનોવેશન કર્યું પછી બેઠા બેઠા નવું કંઈક વિચાર આવ્યો કે પાવાગઢ ગયા હતા ને ત્યારે પેલી ટ્રોલી પડતી તો ટ્રોલી જોઈને એમાં અ, એ ટ્રોલી બનાવવાનું વિચાર્યું ત્યારે પછી પાવાગઢમાં નીચેથી લઈને ઉપર સુધી પેલી મોટર લગાવીને એની દોરીથી રબરથી પેલી નીચે ટ્રોલી લટકાવીએ અને એની ટ્રોલી સાથે માણસ એમ લટકાયેલો હોય પેલી લટકાયેલું કે તરતું હોય હવે આવું જ નહીં પોઝિટિવ નેગેટિવ કરો એટલે ઉપર જાય પોઝિટિવ કરો તો ઉપર જાય નેગેટિવ કરો તો નીચે આવે એક માણસ લટકવું પડે પોઝિટિવ નેગેટિવ જે કરો ભૂલી તો નીચે આપણે શું કરે પછી સ્વિચ મૂકવી પડે કારણ કે અમુક વાર કેવું હોય તો ચોથા પાંચમું રેન્જમાં નાખીએ એને લોકોએ ટ્રોલી ઓટોમેટિક બનાવી કે એકદમ સ્વિચ ઓન કરી દો અને લિમિટ સ્વિચથી પેલું ટ્રોલી ઉપર જાય નીચે જાય ઉપર જાય નીચે જાય એ બધું બહુ એક્સપેન્સિવ પડતું કારણ કે આ really working towards that, possibly motivated. બરાબર. તો આ બધી વસ્તુઓ ભારત જમાનાથી સ્ટાર્ટ હતી and this is the real era of power electronics, I would say, because I would like to thank Vishwakarma College that will make alive this particular segment of power electronics. And the beginning of power electronics is now, because renewable energy ले लो, power electronics ની normal energy ले लो, कहीं पर ले लो, power electronics is compulsory nowadays. Without it, we can't do anything. So my background, many of years in experience of renewable energy, solar energy. So when we used to take the solar inverters, they were very huge in the size and the capacity it was very low. Nowadays, in the same size, we are getting a megawatt solution of the inverter, which we are manufacturing in Sanand plant. So I would recommend your professor and faculties, please ask student come and just have a look into it. How power electronics will be manufactured, what are the parameters, what are the bill of material. So I got many opportunity in multiple department in the same company, and today I'm heading supply chain management. So I would also recommend professor and faculty, please educate student where they would like to go in field. It is not only the domain of the electrical or electronics, but there are multiple faculties and the process involved in the industries. So some people would like to go in the R&D, somebody would like to go in the engineering. A few of people having a skill of knowledge in sales to sell it out the product. So it is better to make them educate at the stage of their professional beginning in the fourth year. I would seventh SEM or eighth SEM, correct? So make them understand about the processes of the industry, so they can choose their own profession. Because many of time we face few issues of the when we are conducting GE or GET, they're not cope up with the department where they have been chosen. So sometimes people are good enough in the sales, but they've been become a part of the R&D, and then they are spending certain time, and afterwards they'll got to know that they are not they are not made for the R&D. They are good at certain skills of the sales or the quality or somewhere else. So it is better to make them aware, all the students in the semester of seventh or eighth, whenever they are going for the interaction in the field, they should be aware what exactly they have been made for, and then they can choose their own faculty or the process. So that's it from my side, because I don't have much to say. Thank you very much.
Thank you, sir, for sharing your story. I think almost all of us can relate to such childhood stories. Now I would like to invite the principal of VG Chandkheda, Dr. V.S. Firani, to share a few words and inspire us.
Very good evening to all. Uh, our esteemed guests today, J.K. Soni sir, Ramesh Ramanand sir, and all fellow Hitachi Hi-Rel officers, knowing them since 2 years, and colleague faculties, Dr. Trivedi sir, and all department faculties and dear students. I'm indeed very happy to be with you, and but feel sorry also because I gave some time and was unable to meet that meeting of that time which we have decided. Uh, I am so happy to come before you and to share few or my thoughts that Hitachi Hi-Rel, when before 2 years when we started one journey of by after signing the MOU, I have seen the love for power electronics discipline in every one of them. Those who are sitting here with me on the dais, their commitment for the attached with the academia, and over the time always supportive and available with us for any sort of discussion in terms of technical parameters, or research or innovation, their availability is giving us some good inspiration. Dear students, my last 3 days, including today, I was reviewing some doctoral and postdoctoral fellowship programs candidates, and many are postdoctoral were after PhD from across the country and from different discipline, and those who are pursuing PhD. Frequently, we are going for some interviews for selection and all, and our institute is again having good responsibility and opportunity to pursue in the startup and innovation. In this context, and post implementation or post AI based activity into 2022, entirely our study, our job profile, our startup innovation research are all get changed. Majority of research paper or research proposal we have reviewed in last 3 days, they are mostly on parametric study. After working large number of research paper or publishing papers and submitting thesis, hardly we find some practical usefulness. Recently, this week was the last week for submission of the postgraduate thesis from the institute. So all department have postgraduate program is running in our department, and the kind of dissertation we have submitted, I found there are immense opportunity and possibilities to improve the quality of our academic delivery. Why I am sharing this? Because I have seen that thesis of power electronics department also as well. Gone through what are the conclusion where this post graduation study was carried out, and either after the BE or after the ME, ultimately we are pursuing our career. In that case, what is the best possible during your stay, either in your UG mainly and for the PG? The institute or industries like Hitachi Hi-Rel always ready to help and support our research idea, our innovative strength, and I'm happy that good number of startup projects, good number of dissertation are being contributed by the power electronics department. I'm satisfied when I have gone through their thesis. Majority of the thesis were supported by the industries, leading industries of the state, and students studying with that commitment was worth appreciating. So at this stage, totally in transition phase for both academic delivery as well as pursuing of the career. તમે લોકો જ્યારે કેરિયર કાલે શરૂ કરવા જઈ રહ્યા છો ત્યારે what are the available opportunity, કઈ અત્યારે બની રહી છે તમારા કેરિયર બનાવવા માટે, where you can contribute which can lead to you a fruitful career. This is worth investing right in the campus itself. બહાર નીકળ્યા પછી તમારી પાસે કોઈ જ રસ્તો નહીં હોય કે ભાઈ કઈ જગ્યાએ જવું, then it will be trial and error. So if you want to pursue higher study, if you want to make a competitive exam preparation, or if you want to move for that discipline where you are all destined, ઘણી બધી વખત એમ થાય કે તમારી બ્રાન્ચમાં મારું આમ એક ઓવરઓલ ઓબ્ઝર્વેશન હોય કે ભાઈ આપણે તો મેરિટમાં સૌથી પાછળ હતા એટલા ઇન્સ્ટિટ્યૂટમાં આવ્યા. Maybe a grace of the Almighty or grace of the destiny that you put in a discipline which is in today's context having highest potential for pursuing the career, either as an employee or as a self-employment, or in the research and consultancy, or in a product development. So as per my beliefs, as per my knowledge, there exist immense opportunities. And today, when you are all mentored and inspired by some sort of uh, facilitation by a company like Hitachi Hi-Rel, carry out the kind of such activities in the department. Our regular study, this is very well discussed among our academia, that how is the relevant to go as per the timetable based study. Just as a timetable at 10:30 to 12:30, then 12:45 to 3:45 and up to last leg. એમાં પછી ઘણા બધા ક્લાસમાંથી લેવો અને છોકરાઓ વહેલા તમે લોકો જતા રહો. Instead, what you can convert your stay in the campus doing such innovative research, innovative innovation, and that you can start giving shape to your career right from your undergraduate study level. With this, I once again welcome and thanks to all Hitachi Hi-Rel officials. They came, gave their timing, and inspire us, our faculties, our students. And my best wishes, dear students. We are sincerely working hard for how best we can do for you in this campus, which can give you not only the pride for you being this institute student, but of course to guide you in the best direction of the career what possibly you can achieve. Thank you so much and best wishes to you all. Thank you.
Thank you, sir, for sharing the information of power electronics. Next, I would like to invite our esteemed guest, Mr. Dhaval Patel from Hitachi Hi-Rel Power Electronics, to brief us about today's program and say a few words.
Thank you. Good evening. So, uh, actually, most of the things is to be already explained for the power electronics by my seniors and the principal sir. How many are or means from electrical branch? Power electronics? All are power electronics or electronics? कोई नहीं. जो भी इलेक्ट्रॉनिक्स है, इलेक्ट्रिकल है, पावर इलेक्ट्रॉनिक्स है, अकॉर्डिंग टू मी दैट एनी ब्रांच मीन्स जो भी आप सब्जेक्ट्स ले लो आप तीनों ब्रांच के राइट ना ऑलमोस्ट इट वाज इक्विवेलेंट टू ईच अदर्स little bit different but almost equivalent to each others. So my request is that if you are thinking lot for any particular point of topic, right, but my suggestion is that you have to go into the depth for that one. Imagine कि सब सोनी सर ने बोला, रमेश सर ने बोला कि 20 साल से 20 साल में इतना प्रोग्रेस हुआ, 2 HP मोटर इतना ड्राइव बना रहे थे, अभी ड्रॉवर में फिट हो जाता है, तो कैसे हुआ है? हाउ द इनोवेशन गोज सच अ फास्ट वे? तो इसका एक ही आंसर है कि जो भी जनरेशन आ रहा है नया, वो कुछ नया लेके आ रहा है. पुराना जनरेशन तो है ही, उसका एक्सपीरियंस काम कर रहा है, पर जो नया जनरेशन आ रहा है, दे आर ब्रिंगिंग द सम न्यू थॉट्स. उसी से एक इनोवेशन डेवलप होता है और वही थॉट्स आगे जाके एक प्रोडक्ट में कन्वर्ट होता है. सो वी ऑलवेज वेलकम्स द न्यू कमर्स हु आर थिंकिंग इन अ डेप्थ, बट उसके लिए बेसिक आना जरूरी है. अगर आपको डायोड कैसे काम करता है, ट्रांजिस्टर कैसे काम करता है, आईजीबीटी कैसे काम करता है, वो नहीं आएगा, तो यू कैन नॉट फाइंड आउट द रीजन कि गैन और एसआईसी कैसे काम करेगा, जो नए डिवाइस है, राइट. सो एवरीवेयर द न्यू थिंग्स इज टू बी कम आउट. जैसे मैं 2000 में पास आउट होके निकला था, तो एट दैट टाइम आई हैड नेवर हर्ड द सम सिमुलेशन टूल्स, कोई सॉफ्टवेयर. अभी मैथलैब किसने सुना है? सबने, एवरीबडी इज यूजिंग मैथलैब. ओके, पर जब 2000 में हम काम करते थे, तो एट दैट टाइम वी डोंट हैव दैट टूल, राइट. तो वी आर फेसिंग द सो मेनी डिफिकल्टीज. कोई एक सर्किट बनाया, 10 आईजीबीटी उड़ गया, फिर से बनाया, दूसरे 10 लिए. So nowadays you have to learn the MATLAB or tool, such a simulation tools जो past experience का एक output है. So you can easily simulate the circuits and make the new circuits, right? तो सिर्फ MATLAB में simulate करके वहीं पे stop नहीं हो जाना है. जो भी सर्किट आपने सिम्युलेट किया है उसको एक प्रैक्टिकल मॉडल में कन्वर्ट कीजिए. then and then you can get the good results, right? use the tools, simulation tools, क्योंकि ये जो फास्ट इनोवेशन हो रहा है, फास्ट ग्रोथ हो रहा है, due to this software tools also, it plays the very important role in this. एनसिस किसने सुना है? only one person? It is also one of the strongest simulation tool in a current scenario. Okay, or fortunately your college has the license for this thing, so I request that use that license to learn that tools, जिसमें you can design or you can simulate the complete thermal flow, heat sink temperature flow, means heat sink flow, everything you can simulate. जो आप डिजाइन कर रहे हो, जैसे आईजीबीटी का कितना टेम्परेचर जा रहा है, इतना पावर फ्लो करूंगा तो कितना टेम्परेचर उस एरिया पर्टिकुलर स्पॉट ऑफ एरिया में जाएगा. सो आई रिक्वेस्ट, because your faculties has already purchased that means software which so many industry doesn't have. तो यही पीरियड है कि आपका जो ड्यूरेशन है, जो एकेडमिक पीरियड है, यूज दिस सॉफ्टवेयर लाइसेंसेस विच विल improve your thinking power also. कि आपने जो मैथलैब में एक मॉडल बनाया, उसी मॉडल को आप एक फिजिकल मॉडल में कन्वर्ट कीजिए, जो भी आप डिवाइस लेना चाह रहे हो, and then simulate into the ANSYS model. You can find out the exact reasons. The reason why the technology going such faster, उसका रीजन एक ये भी है कि ये जो सारे सिमुलेशन सॉफ्टवेयर्स आ रहे हैं, उससे रिपीटेबिलिटी कम हो रहा है, फिजिकल ट्रायल्स लेने का कम हो रहा है. सो आई रिक्वेस्ट कि अभी भी देयर आर सो मेनी थिंग्स, एंड रिक्वेस्ट टू रिमूव द फेसबुक फ्रॉम योर मोबाइल, और ऐसा टूल डालो कि जिसमें आप सो आई एम नॉट सेइंग दैट देखिए ही मत, बट गिव मोर टाइम ऑन दैट वन. अभी एकेडमिक पर्पस के लिए ये सारे टूल्स आपको most of the trial license are to be available for your academic purpose, right? जो आपको इंडस्ट्री में जाके बहुत यूजफुल हो रहे हैं वाले. So I request this 3 to 4 tools, that MATLAB, PSIM, or this ANSYS, which was very good for the simulations. So that is the first point which I want to tell you. दूसरा जो बेसिक है उसको मत भूलिए, क्योंकि वो तो जरूरत पड़ने ही वाला है, राइट? तो बेसिक एक ही रीत से आता है कि यू कैन लर्न मोर, मीन्स रीडिंग पावर, यू कैन इंक्रीज योर रीडिंग पावर. अभी बहुत सारे रिसोर्सेज है, यू कैन रीड फ्रॉम द गूगल, यू कैन रीड फ्रॉम द एनी सोर्सेज, बट यू रीड द बेसिक ऑफ पावर इलेक्ट्रॉनिक्स. So for that purpose, we are also sharing the some good books to the college library of the power electronics. I request all of you, please use that books. Otherwise वो धूल खाएंगे और यहीं पर पड़े रहेंगे, right? And third, सबसे important बात है कि फैकल्टी को सब आता है ऐसा नहीं होता है, right? I will explain you, means I will share you one example. जब मैं कॉलेज में था, at that time the C language is very new for me. Okay, so my faculty knows only assembly language. तो एक दिन बताया कि मेरे को थोड़ा आता था उसमें C language. So my faculty sit against to me and he told me that you take the lecture of C in place of me. So for my last year, complete last year, I had taken the C language for the other student also. So it is not like that कि faculty को भी सब कुछ आता है. They at any time we have to be learn everything in industry also. जो अभी हमारे जो कलीग्स हैं उनसे हम सीखते हैं, वो हमसे सीखते हैं. So the learning is from both the way. So you should always think in that way कि इनसे ज्यादा बेहतर कैसे कर सकता हूँ. आईफोन कैसे बिक रहा है, किसी ने स्पेसिफिकेशन बढ़ाए, आईफोन इतना रैम दे रहा है, इतना फ्लैश दे रहा है, उसका डिस्प्ले इतना रिजोल्यूशन वाला है. कोई मेरे को एक बताओ आईफोन 17 का स्पेसिफिकेशन बताओ. इट्स ओके, मेरा आवाज ऐसे भी बड़ा है. किसके पास आईफोन 17 है, 16 है, 15 है, किसी के पास तो होगा ही, पक्का है. जिसके पास भी सैमसंग का भी फोन है, राइट, तो स्पेसिफिकेशन बताते. S26 है, उसका स्पेसिफिकेशन तो पता होगा, राइट ना. आईफोन का पता है नहीं, यूजर है ना, पर किसी को भी पता है. पर जब से ज्यादा पैसा वही लेता है. Why the people are not comparing the specifications of iPhone? क्यों? Because they believe that they are giving something new to us. और ऐसा भी एक पता नहीं सुना है, मैं भी आईफोन यूज नहीं करता, पर ऐसा सुना है कि एक बार जिसने आईफोन यूज किया वो दूसरी बार आईफोन ही लाता है, उसको और कोई फोन अच्छा नहीं लगता, राइट. But we didn't know the specifications because iPhone is not giving any specification to anybody. So that is also the one of the way to innovate that thing. शायद से ऐसा भी हो कि वो S26 से कम फीचर्स दे रहा हो, पर तो भी पैसा डबल ले रहा है, राइट. So everybody knows the result, कि रिजल्ट कैसा है. तो आप कुछ ऐसा थिंक कीजिए कि जिससे कुछ आगे कुछ काम आए. And this is what I learned from my one of the means my guide is there in my final year practical. कि मैं PRL में जा रहा था और वहाँ पे my guide is working on the that moon mission, satellite moon mission. तो हम जब जाते थे ना तो उन्होंने एक 8051 सुना है सबने, प्रोग्रामर, राइट. तो उन्होंने पहला प्रोग्रामर बनाया था और उन्होंने खुद का प्रोग्रामर बनाया था, right. And that is right, that MS Mazumdar is the guide name and he is making his own programmer, right, 8051 controller programmer. And he put up a one photo, his photo on that programming tool, ये मैंने बनाया है. और मेरे साथ ही मेरा कलीग्स थे जो अभी हमारे साथ ही है, हिटाची में ही है, राइट. He had made the same programmer and then given to him. So he immediately removed his photo from that tool. कि नहीं ये तो किसी और ने भी बनाया है, मैं अकेला नहीं हूँ. So till that time that he knows that कि नहीं मैंने ये सर्किट मैंने अकेले ने बनाया, पर यशपाल one of my colleague is there with me. So he is the same programmer on the very first day when we joined his under him. ऐसा मेरे पास भी ऐसा प्रोग्रामर है. So he immediately removed that photo उसके टूल से. So ऐसा नहीं है कि कोई नहीं बना सकता. उस वक्त हम वेरी न्यू थे, तो उस वक्त उन्होंने मेरे को एक क्वेश्चन पूछा था कि केबीसी देख रहे हैं ना सब, केबीसी देखते हैं, तो केबीसी में जो बजर बजता है, तो पहला बजर वो जो सिस्टम रहता है पूरा, उसका हमको इलेक्ट्रॉनिक्स डायग्राम बना के दिखाओ, ऐसा पूछा था. एंड आई विल गिव यू 5 मिनट्स. उन्होंने उस वक्त हमको, दिस इज इन 2002, राइट. एंड ही टोल्ड मी द सेम क्वेश्चन कि जो पूरा सिस्टम रहता है बजर सिस्टम, वो पूरा बजर सिस्टम का आप मेरे को इलेक्ट्रॉनिक्स डायग्राम 5 मिनट में बना के दिखाइए. आपके पास 5 मिनट है. अगर आपने 5 मिनट में बना के दिखा दिया तो आई विल कीप यू इन अंडर मी, अदरवाइज यू गो आउट। चलो आपको मैं 2 मिनट देता हूँ, 2 मिनट में बना के दिखाइए। कोई बता सकता है? दूसरे दिन हम पूरा है ना उसका एक बड़ा सा चार्ट पेपर बना के लेके गए, सारे गेट्स और वो सब जोड़ के, और फिर उनको बताया ना तो उन्होंने फाड़ दिए कि मैंने आपको 5 मिनट ही दिए थे। Imagine that then he stand up and he draw the one square box, he write the one microcontroller inside it, he giving the 4 input and 1 output, nothing else। बन गया। यही होता है सिस्टम में, बाकी तो काम सॉफ्टवेयर ही करता है ना। तो एट दैट टाइम वी डोंट हैव दैट मच थिंकिंग पावर, पर अभी है। तो आई रिक्वेस्ट ऑल ऑफ यू कि जितनी सोच सको उतना सोचो, उसका कोई लिमिटेशन नहीं है। ऐसा नहीं है कि मेरे फैकल्टी ने मेरे को इतना ही पढ़ाया तो मैं इतना ही पढ़ूंगा। गो बियॉन्ड ऑफ दैट ऑन। ओके, थैंक यू।
Thank you, sir, for briefing us about the minute details of power electronics. Now, I request our esteemed guest, Mr. Dinesh Thakur, to say a few words.
Good evening, everyone. First of all, I would like to thanks VGEC team, especially Power Electronics department, to provide the support. Even when we required from the VGEC, they are always ready to provide the support also. See, this journey start in 2012. From my side, I can say that at that time we are interacting with the VGEC as well as this Ali Murvi Engineering College also. And there is a two branch power electronics branch in the Gujarat state for this, right? Since last 2 years, we are closely working with VGEC Power Electronics team how to bridge the gap between the industries and academia. So, since last 2 days, we are working on this power electronic kit distribution project. I told Mr. Vani and Trivedi sir, may have total overall students in power electronics. They said you may consider 208 to 10, not more than that. I said, "Okay, for one semester, then he said, can entire power electronics branch from semester 1 to semester 8, there is a total of 100 students." So, rightly said by the Best and Purani sir, power electronics branch is considered as the lowest voltage. They said कि जिसको कहीं नहीं मिलता है वो power electronics में आता है, and those parents they don't want to send their kids to the other cities or anywhere, so वो लोग आते हैं. Now I will say things from industry's point of view. 210 का power electronics है. You go to the Sanand, Hitachi Hi-Rel, CG Power, you go into Minda, Ampere, Movement Technologies in Baroda. You think that what is the future of power electronics and what are you doing? आपको ऐसा लग रहा है कि पावर इलेक्ट्रॉनिक्स में कुछ है नहीं, यू कंसिडर तो कुछ नहीं है, इंजीनियर हो जाएंगे. वी कैन सी दैट देयर इज ओनली 50 स्टूडेंट्स पर per year they will pass out, and there is a huge companies they are coming into the Gujarat for power electronics and other equipments manufacturing. Means there is a huge demand of power electronics engineering in the market. So when we came for a campus placement, then we many times we observe with the technical team also to they don't have a much more identification for the instruments and kit also. So the idea came to us that why we cannot distribute the power electronics kit. At least when they appear in any campus, at least we should have a knowledge on that. Yes, these are the components we generally use in the power electronics. Right? So I once again I request all of you consider power electronics is the future of the industries also. You learn and you apply in all the campus also. And I think Purani sab nahi hai idhar, but I request to the VGEC management also that uh, there is a single college of power electronics in Gujarat. When we identified total national level pan India, there is a top college in power electronics. So, if possible, you can introduce more colleges into the power electronics branch also. This will be, I think, the gap will be bridged by introducing new power electronic branch in different college also. Thank you and all the best. Thank you.
Thank you so much, sir, for enlightening us with such warm words. Now, let me introduce you to Mr. Darshan Shah, MD, Hitachi Hi-Rel Power Electronics Private Limited. Darshan is a graduate from Purdue University, USA in Masters of Science in Control and Robotics and RD College of Engineering, Ahmedabad. He is with this company since 1993 and was elevated as Managing Director in 2022. He served as the Chairman of CII Gujarat State Council for 2023 to 2024. He is also a senior member of Institute of Electrical and Electronics Engineering, an honorary member of IEEE ETA, Society International Honor Society of IEEE. Now moving ahead, I request Mr. J.K. Soni and Mr. Ramesh Ramanan to distribute brochures highlighting Mr. MD Sir's Mr. Darshan Patel's message to the students. I invite the students of ME to kindly come forward. Now let us move forward. Moving forward, I request Mr. J.K. Soni to distribute book to the Power Electronic Department. For that, I request Dr. Anand Trivedi sir to accept books on behalf of Power Electronic Department. Now, moving ahead, I would like to say few lines for the efforts made by Hitachi Hi-Rel Power Electronics Private Limited from whole Power Electronic Department. ज्ञान के साथ प्रयोग का अवसर भी दिया है ज्ञान के साथ प्रयोग का अवसर भी दिया है इस पावर इलेक्ट्रॉनिक किट से हमें एक नया अरमान भी दिया है दिल से आभार आपका दिल से आभार आपका आपने हमें हमारे भविष्य को एक नई पहचान दिया है May I now call upon Dr. Anand Trivedi to express the vote of thanks.
Good evening to all of you. I am here to convey the vote of thanks. First of all, I am thankful to the company Hi-Rel Hitachi, their officials, and their all colleagues for designing such beautiful thought process that something should be given to students which can be useful to all in a small packet, right? So this is first thing. So really, I am thanking the whole team by my heart. Secondly, I am very much thankful to the principal sir also. We have done MOU with the company, and as you can see that all the team members, including two vice presidents and their colleagues, are present here to give you the thoughts on a small kit. आप उसका लेवल देखिए तो बहुत एक्सपीरियंस्ड है, बहुत टॉच पे बैठे हैं, फिर भी आपके लिए जो सोचा वो एकदम बेस से सोचा और बेस से बोला है। यदि वो अपने लेवल से कुछ देना चाहते हैं तो आपको पूरा फंडामेंटल किट दिया है कि यू कैन डू समथिंग आउट ऑफ दैट। सो माय सिंसियर थैंक्स गोes to the whole team and company. So I want to convey my thank you to all the students because you were waiting for rather 45 minutes, I think, right? But it is the time. So thank you all, and I wish you all the best. And thank you again to the Hi-Rel Hitachi.
Thank you, sir. As a token of memento, I invite two of Hitachi Hi-Rel to present a memento to our respective professors of Power Electronics Department. MS Alwani, sir. MS Alwani, sir. I invite Dr. Ryan Trivedi, sir. I now invite Professor M.D. Makwana. I now invite Dr. E.M. Huxley to kindly come forward. I now invite Professor H.S. Vani sir to kindly come forward. I invite Professor H.S. Trivedi sir to kindly come forward. I now invite Professor Ashish Patel to kindly come forward. Lastly, thank you everyone for being the part of this program. I now invite Andy sir to kindly come forward and accept the memento from Hitachi Hi-Rel. मजा आई ना? Lastly, thank you everyone for being a part of this program. Now we have reached the end of this wonderful session. बोले? Finally, it's time for a group photo to capture these memorable moments. We will have the esteemed guest and faculty members first move, and then all the students can follow.